Hey there, it's Dina from IDon'tGetItTutoring.com. Today we're going to be solving one variable equations. Let's get started. So before we start, we need to know the difference between an expression and an equation. An expression is a statement with only terms. For example, 2x plus 5. It is always true because there's no solution. Any value of x goes, and it has to be right. For example, if you were to plug in 1 for x, 2 times 1 plus 5 is 7. And then whatever value of x you put in, you're always going to get a result from it. Unless you get something that's undefined because there is a 0 in a denominator of a fraction. But those are in rare cases. But more than likely, an expression is always going to have some sort of result. Now, an equation is basically an expression with a preset result, meaning 2x plus 5 equals 10. So the formal definition of an equation, right? Expression that equals something. And from the word equation, equal, so you could kind of get it from the word itself. Now, 2x plus 5 has a set solution, so there's only a certain amount of values of x, in this case, it's probably 1, which will give you this desired outcome. And that is what we're going to learn today, how to figure out what x is. Now, equations can have different amounts of solutions or answers. They can have one, they can have infinitely many, or they could have no solutions. So one solution is, for example, x plus 3 equals 5. Only one number plus 3 can equal 5. And what's that? 2. Very straightforward. For example, 3 plus 3 is not equal to 5. It's not possible. But only 2 plus 3 is equal to 5. There's only one solution, one value of x that makes sense. Infinitely many, like infinite, there's an infinite amount of answers that x can be. Any value of x works. So, for example, we could do x plus 3 equals x plus 3. Of course, anything is equal to itself. So if you were to put, let's say, 2 for x, and we solved, 2 plus 3 is, of course, going to be equal to 2 plus 3. 5 is equal to 5. Or if you were to put, let's say, 3 for x. So 3 plus 3, does it equal 3 plus 3? Of course it does. 6 is equal to 6. So yes, infinitely many solutions. And no solutions is exactly as it sounds. There is no value for x that will make the solution work. So, x plus 3 equals x. Nothing plus 3 equals itself. It's not possible. Let's say 1 plus 3 is 1. Obviously, it's not, because you're doing something to the number, so it can't go back to its original form with only one operation. So, those were the three types of systems of equations, but today we're going to be focusing with those with one solution. So, let's get into it. Let's do 2x plus 5 equals 11. One variable, our variable is x. Let's go through the steps. So, what we're trying to do, in order to find x, we want to reverse the operations that are done to x. So what we have to do is start with the one that's farthest away from it. Our goal is to find x, right? So we need to isolate it in order to find it first. It's super, super important. Remember, reverse operations done to x and the goal, what's our goal? Find x. So let's get started with some steps. We need to first identify the operations and the order they occur in. Without doing this, we won't be able to reverse them, because without knowing what happens when, how are we going to be able to reverse it? So, what's happening to x over here? First, the closest thing that's being done to x is it's being multiplied by 2. Next, after that, it's adding 5. So 5 is being added to it. So our order of operations would be first multiplying by 2. And then adding 5. Now, what we need to do is reverse this and the operation itself. So it's not just like moving the order in which it's done. We also need to do the opposite operation. So what is the opposite of addition? Subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. And the opposite of division is multiplication. So those are opposite operations. So not only are we changing the order and reversing it, we're also reversing the operation. We're doing the opposite operation. So those are the operations being done. And now we need to first, our next step, which I kind of already started going into, is reverse the operations. Now, we're going to take our latest one, which is 2, and we're going to go farther to the earliest and earliest. So we start from the latest and we go to the earliest. Last to the first. So, our latest operation, the very last thing that happens to x, is adding 5. So, we need to do that first. We need to, what's the opposite of addition? Subtraction. So we need to subtract 5. The numbers stay the same though. We don't do anything to the numbers. It's just how the numbers are being applied is what changes. So 5 doesn't turn to -5. Well, it does turn to -5, but it doesn't turn to 1/5 or 0.5. None of that. We keep the 5 as it is. So from adding 5 from +5, turn into -5. So that's why I said -5. So we're subtracting 5, and then What's the opposite of multiplication? Division. So we're dividing by 2. And now, let's put it all together for our third step and solve. Reverse and solve. So 2x plus 5 equals 11. So our first step, subtract 5 from both sides. Minus 5, minus 5. Okay, 5 minus 5 is 0, so that cancels out. So we just have 2x plus 0 equals 11 minus 5, 6. We don't need the 0, 0 is invisible, so 2x equals 6. Next step, divide by 2. So we divide both sides by 2. 2x divided by 2, the 2 cancels. So we have 2 equals 6 divided by 2, which is 3. So the value of x is 3. And there we go. You just solved an equation with one variable. Let's try another one, a little more complicated one. Now, here's one that's a little more complicated. Something that might seem a little weird. X plus 7 divided by 2 equals 10. Whoa, why is there a fraction here? That's really, really weird. What is this? Nothing we can't handle with our steps now. Let's make a list. What's being done to x? First, we're adding 7. After that, it's over 2. Over 2, the fraction over 2, means division. So it's being divided by 2. Now, what we need to do is reverse it once again. So the opposite of division is multiplication. So we need to first multiply both sides by 2. And then after, we need to add 7. Sorry, not add 7, subtract 7, because the opposite of addition is subtraction. So subtract 7. Okay, now let's put it into our equation. Let's first multiply both sides by 2. This whole fraction times 2 cancels because it's over 2. So we're left with x plus 7 equals 10 times 2 is 20. Then subtract 7 from both sides. X plus 7 minus 7. 7's canceled because it equals 0. 20 minus 7 is 13. And 0 doesn't need to be there, it could be invisible. So x equals 13. And there we go. And if you're skeptical, you could always check. You could always plug in what you got for x as x in the equation to make sure you still get 10. So we could do that right now. Let x equal 13. 13 plus 7 over 2. Does that equal 10? Let's see. 13 plus 7 is 20. Divided by 2. 20 divided by 2 is 10. So yes, 10 is equal to 10. 13 is correct. There we go. Let's do one last example. One that's a little more complicated, just a few more steps. This one will be, okay, a little more room for this one. Okay. 3 times x minus 5 over 4 plus 11 equals 30. So one added step. Pause the video, try to do it yourself, and I will start doing it now. Okay, what operations are being done to x? Let's write them down. First, what's next to x? Minus 5. So first, we are subtracting 5. 5 is being subtracted. Next, right next to that is 3 outside of parentheses. So 3 parentheses multiplying by 3. That means multiplication. Multiplying by 3. After that, you see the whole thing is over 4, so that means it's being divided by 4, like we did in our other example from before. And then finally, right next to that is plus 11. So that means after that, 11 is being added. So now, reversing, what do we need to do? First, we need to, opposite of add, subtract 11. After that, multiply, not divide, multiply by 4. Then divide. So first we're dividing. That's why it's the opposite, multiply. So first we multiply by 4 because we switched the operation from division. And now that it's multiplication, now how before it was multiplying by 3, we're switching that and turning it into dividing by 3. And then finally, subtracting 5 becomes adding 5. And then those are all of our steps. And then after this, we should be able to find x. Let's do it. Okay. First, we need to subtract 11 from both sides. So minus 11, minus 11. That cancels. 3 times x minus 5 over 4 equals, what's 30 minus 11? 19. Okay, 3 times x minus 5 over 4 is 19. So this is our first step. Done. Next, we have to multiply by 4. So we multiply this whole thing by 4. Once again, 4 cancels since it's in the denominator. And then we do 3 times x minus 5 equals 19 times 4, which is 76. After that, we can divide by 3. Once again, 3 cancels, it's in the denominator. We're left with x minus 5 equals 76 divided by 3. And 76 divided by 3 gives us a decimal. And to make this easy, I am going to leave this as a fraction, so we're not dealing with like super long decimals. So 76 divided by 3 equals x minus 5. Finally, we have to add 5. So we add 5 on both sides. This cancels because it equals 0. X minus 0 equals 76 divided by 3 plus 5. And when you simplify that into a fraction, x equals 91 divided by 3. So boom, last step done, and then we finally found the value of x. You can always check to make sure that that is the right value of x. I checked it beforehand and it works. So that's it. I hope you found this video helpful. Thank you for watching. That's it. Bye.